This tutorial will show how easy it is to perform an analysis of stage construction using the nonlinear capabilities of SAP 2000. We start with a simple 3-story 2-bay frame where each story will represent a stage of construction. We will remove the center first floor column in order to create a transfer girder. This girder will be susceptible to stage construction because it carries gravity loads from the floors above. The key to doing stage construction in SAP 2000 is to identify each stage as a group. In this case, each story or stage will be represented by a group. Repeat this process for each story, selecting and then assigning the objects to a new group. Next, we define the static load cases. For this example, we will use only the self-weight dead load case. Next, go to the Define Analysis Cases. We will delete the predefined modal case as we will not be doing any dynamic analysis. To the dead load case, we will add 3 additional cases, 1 for each stage of construction. Name the first new case Stage 1, make sure that 0 initial conditions is set, and select the nonlinear option. Set the analysis option to static, and use the dead load case as the applied load. Loads are applied only to the new stage as the analysis sequence progresses. Click on the Modify Show button for the stage construction option to identify Story 1 as the active structure for Stage 1. Add another analysis case named Stage 2, but this time continue the analysis from the end of case Stage 1. Again, click the Modify button for stage construction and identify Story 2 as the active structure for Stage 2. Repeat for Stage 3, using Stage 2 as the starting point. And Story 3 as the active structure. We now have a linear static dead load case and 3 nonlinear static analyses cases representing the stage construction of the 3 stories. Now that all the analysis cases are defined, we are ready to run the static analysis. Change the 3D view to an elevation view with the dead load case displayed. In the right window, we will display the deformed shape from the staged analysis cases to see the effect that this loading approach has on the building. We start with Stage 1 and Step 10, which is the last step. Set the scale factor to 50 to match the scale on the left. Add the next story with Stage 2. And then the top story with Stage 3. A right-click on the middle joint for the linear case shows a displacement of about 1.5 inches, while the same location in the nonlinear staged analysis gives a result of almost 3 inches, nearly double. Next, change the left window to show the moment diagrams for the linear dead load case. In the right window, we will again show the results for the stage construction case. Starting with stage 1, step 1. Again, we set the scale factor to match the left window. We can toggle up through the steps to see how the displacement changes. At step 10, the last step, the moment is approximately 19 kip inches. Next, we add in stage 2, or the second story. And the moment jumps to 39 kip inches. Adding on the third story, the moment in the transfer girder jumps to 51 kip inches, more than double that of the linear analysis, where the entire structure works together to span between the columns. This concludes this tutorial.